Good morning. Today we are going to discuss the Chomsky normal form. Chomsky normal form is a part of context-free grammar in which we have to convert the given production rules into the Chomsky normal form so that we can easily understand all the production rules. If you want to define the Chomsky normal form, then we can define the Chomsky normal form by this. If a CFG has only a production of the form which is starting from the non-terminal node to the string of maximum two non-terminal nodes, or non-terminal node will starting from that which will end into the one terminal node, then that context-free grammar is known as Chomsky normal form. So Chomsky normal form we can get from any context-free grammars by removing the various null productions and unique productions. And for that, we have to follow the certain process or theorem. All the non-null words of the context-free language, which always being generated with the use of corresponding context-free grammar, which is actually a Chomsky normal form. That is, the grammar in Chomsky normal form will generate the same language except the null string. Following is an example. Let's discuss some of the examples through which we can be able to learn how we can convert the given context-free grammar into the Chomsky normal form. Let's say the one examples over here in which the context-free grammar has, we can say these are the various production rules of given the context-free grammar, in which S is an initials starting symbols, okay, and then here we can say all other symbols A and B are known as non-terminal terminal nodes, while S is a terminal non-terminal nodes. Okay, if we want to convert this given grammar into the Chomsky normal form, then we have to follow the certain rules and regulations. Okay, so if we want to convert the given production rules or context-free grammar into the Chomsky normal form, then we can convert or create that with the use of 4 different steps. There are 4 steps are involved through which we can be able to convert the given context-free grammar into the Chomsky normal form. Okay, in this particular grammar, you can see that S is ended. If we want to replace the initial starting symbol, then we can replace by ASA, then by, or we can replace by the BSB, or we can replace by A or only B or double A or double B. So this is the given context-free grammar, in which first step is we have to remove the all the we have to convert this context-free grammar into the Chomsky normal form. For that, what we require, we have to first thing which is required, that is all the combination of non-terminal node with the terminal nodes both should not be present in the production rule. So that's why here we have to replace all the terminal nodes by non-terminal nodes. Okay, so here we have to remove this small a we have to remove. Here we have to remove the small b, all small a, small b, and so on. All the small a and small b which are combined together, other than this only single terminal node, we have to replace that by the another non-terminal node. Okay, so that is possible to be achieved with the use of by adding more production rules, which can lead towards this terminal node. So we can add this kind of rule by taking some new productions starting from A to small a, and we have to replace the small a by the capital A. Same way we have to replace the small b by the capital B, through which we can say that all the terminal nodes in the given production rules are removed by the non-terminal nodes A and B. So if we want to rewrite the entire statement, then we can rewrite that entire statement by this particular way, with S starting from ASA, where A, S, and A, all the three are, we can say, non-terminal nodes. They are initially the terminal, it is combination of both terminal as well as the non-terminal nodes. While after introducing these two production rules, we have removed this combination of non-terminal with terminal by replacing all as a non-terminal nodes. So we can write down BSB as a capital BSB. We can write down the AA and BB by capital AA and BB. Both capital A and BB are over here known as a non-terminal nodes. But we are not going to replace this small a and small b because they are only a combination of, they are not just the combination of terminal and non, they are only just the terminal nodes. So we are not going to replace the terminal node. We are only going to replace only those rules, those production rules, which is the combination of both terminal node as well as non-terminal node. So after adding this, we have to add two more production rules that we have introduced initially. Okay, so this one is the first step through which we can say that through which we can convert all the production rules with either having only a terminal nodes or non-terminal nodes. Okay, this is the first step. Now let's discuss the second step. Second step is all about whatever the number of non-terminal nodes which are available, which is starting from non-terminal to the another non-terminal nodes. All the non-terminals should be maximum of 2 size. Okay, so here initially we can see that here ASA, the total number of non-terminal nodes are 3. But in the according to the Chomsky normal form, the maximum number of nodes which are allowed, maximum number of non-terminal node together allowed are 2. So what we have to do, we have to introduce the new production rules, which is the which we can lead towards the SA by introducing the one more non-terminal node. So we can replace this SA by some another symbol AR1. Okay, then where we can say that R1 is leading towards the SA. So ASA is replaced by AR1, where R1 is again replaced by with the use of SA. Okay, so maximum 2 non-terminal symbols we can combine together. Okay, same way we can say that BSB, again 3 symbols. Okay, so instead of this SB, we are going to replace the SB by another non-terminal nodes. Okay, so that is, let's say that is R2. So BR2, where R2 again leading toward the SB. Okay, but we are not going to replace this AA because the total number of non-terminal nodes are 2. So that is eligible. Okay, that is valid. Same way we are not going to replace the BB also, or small s and small b also. Okay, so again 2 more new production rules are introduced into this second step, in which the right hand side of the production rules should have the maximum of 2 non-terminal nodes. Okay, this one is the second step. Let's discuss the third step. The third step is regarding removal of nullable productions. Nullable production. What do we mean by the nullable production? Nullable production means in which if any non-terminal node it leading toward the null string, if any non-terminal nodes leads toward the null string, then that is called as a null production, and we have to remove this kind of null productions in this particular steps. This one is the third step of this Chomsky normal form. So here let's take some example, another examples, which is S is leading toward the AB, where A is leading toward A or null. So we can say A is non-terminal symbol is replaced by the small a or nothing. Same way B is also replaced by the small b or nothing. Okay, so here we have to remove this A to null and A to B to null. These 2 production rules we have to remove. Okay, to remove that, if we want to remove this kind of null productions from that, we have to replace all this A by the another possible way is either replacing that A by A or by null. So you can see that A is available in initial starting symbol production rules. Okay, S to AB, in which both A and B is also available. So that's why one by one, initially the AB and AB is always remain there. AB to AB is always remain there. But suppose if A is null, then what will happen? A could be this, first A could be the null, or second A could be the null, or both at the same time could be the null. Okay, so we can say, if let's take all the different types of possibility in which suppose this A is null, first A. So we can say remaining are BAB. So we can say that you have to add the new rules. that is known as BAB. Suppose if we are replacing this second A by null and remain all the non-terminal nodes remain as it is, so we can replace that by ABB. So you can see that ABB. Okay, same way we can apply, if we are applying both A as a null, then what will remain? Both B, BB. So here we can say that BB will remain as it is. Oh, that is going to be a new production rules. Same way, this is all about if we are replacing A by null. Same way, it is also possible if we are replacing B by null also. Okay, so if we are trying to replace the B by null, we can say that if we are replacing B by first B by null, so we can say AAB. So here you can see AAB. If we are replacing second B by null, it new production will be ABA. You can see ABA is already present even over here. Okay. Same way, if we are replacing both B by null, then next thing is AA. So A is also present over here. Okay. So this is the things how we can replace the all the uh, production rules which are null pointing towards the nulls. Okay, same way we have to apply the same thing to the all the string we have derived so far. Suppose if we are again if we are replacing this A by null, then we will get what? BB. So here BB is already present. Suppose if we are replacing this B by null, then we will replace either AB or BA. So AB and BA is also the possibility of this production rules. In this grammar, if we are replacing A by null, we are getting AB, or we are if we are replacing B by null, we are getting A, which are we already derived this particular grammar already. Same way we can derive all this remaining grammar. Suppose if we are replacing both the A by null, we will get B, only B. So that will be available over here. But if we are replacing A and B both by null, we will only get A. So A is also a possibility. So this is the way how we can get all this so many different types of production rules with the use of only this, starting from A S to AB AB. After processing this null production, removal of null production. Okay. So this one is the third step of removal of null production. Let's say the fourth step of this, fourth and the last step of the Chomsky normal form, that is S to A or B, in which we have to remove the unit production. Unit production means in which if any production rule which is having the starting, which is having, we can say it having only a single non-terminal node, that we have to remove, like S to A or S to B. These are the, if this kind of rules, then we have to replace or we have to remove this kind of single non-terminal node. Okay, so that is possible by replacing the non-terminal symbol by the all the production rules which are available in the list. Okay, so suppose if we know that this capital A leads toward the small a, if capital B is leads toward the small b in the upcoming or the remaining grammar, if that kind of grammars are already available, then we can say that S is pointing toward A, small a, and S is pointing toward the small b. So we can replace by that. Instead of writing only single non-terminal node, we have to replace this single non-terminal node by a terminal nodes. Okay, so whatever the number of terminal nodes production rules are available in the grammar, that we have to replace over here. Okay, these are the all the four different steps through which we can say that we can convert the given context-free grammar into the Chomsky normal form. Okay. This one is the exercise that you can perform, or you can apply all the different types of rules and regulations discussed earlier, and all the four steps, and you can get your result. This is your exercise that you can do. Thank you.